All right, so we're now going to go to 2.2b. We're just going to add everything else in on this. So this should not be anything that like blows your mind, because we've already gone over some of this already. It's just adding period into there. So y equals a sine of b times x minus c plus d. Okay, that's our general format. Okay, so we're going to have y equals -2 sine of 2 times x minus pi over 2 plus 1. Let's graph the whole shooting match here. Okay. Now, since I have nothing but 2's involved, I decided to go to 8 to get to pi. You could have gone to 4 to get to pi. Either way is fine. But you want to give yourself a little bit of room. You don't want to go 2 to get to pi because then it's too squished. All right, so what am I going to graph here? Well, I'm going to graph y equals sine of x. Bless you. We're going to graph y equals -2 sine of x. We're going to graph y, no, that's too close in color. Let's grab a different color. We got green. Let's go light blue. Y equals -2 sine of x minus pi over 2. And then we got our last one. Oh, I forgot about the 2 in there. So this should be 2x. And then, let's go orange. Y equals -2 sine of 2x minus pi over 3. There we go. So we're going to have 5 graphs in one. So we're first going to graph y equals sine of x. Where does sine of x start? 0. So I go 0, 1, 0, -1, 0. Then what does -2 sine of x do to my graph? Stretches it how? Vertically. So 0 times -2 is 0. 1 times -2 is -2. And then 0. -1 times -2 is a +2. Then back to 0. Looks something like that. Then, what does our 2 in front of the x do? Shrinks it horizontally. Shrinks it horizontally. Everything is half as far as what it was. So if there's a 2 in there, you go half as far. So half of 0 is still 0. Half of 4 over is 2 over. Half of 8 over is 4 over. Half of 12 over is 6 over. And then we have a minus pi over 3 going on here. Where does minus pi over 3, what does that do to it? It's a phase shift, so it shifts it which way, right or left? Right by pi over 3. Oh, Mr. Bierschbach. Oh, it's pi over 2. Good. I wrote down pi over 3, but it's pi over 2. And I was going to say, Mr. Bierschbach, you're el stupido. Because I made everything not divisible by 3. So if it's divisible by 3, you need to think about that before you do this. All right, it's divisible by 2. So pi over 2 is 4 squares. So everything, the blue graph goes 4 squares to the right. 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 And finally, our last one. We're going to go everything up by 1 from the orange graph. 1 up, 1 up, 1 up, 1 up, 1 up. I'm sorry. There you go. Okay. Now, you're going, oh, geez, Mr. Bierschbach, this stuff is easy. Well, get ready for mind equals blown here on this next one. Okay? Because everybody, this is no problem. Okay? Because this is just kind of a review, getting it down. Well, Mr. Bierschbach has an example which is not so nice. So I'm not going to have as much involved. Y equals sine of pi over 2x minus 3 pi over 2. Like that. And you think, well, that doesn't look so bad. Well, the problem is we have a pi over 2 in front of our x inside of parentheses with a 3 pi over 2 inside of parentheses. So, since it's inside of parentheses, I better factor it out, huh? Well, when I factor it out, what is left? Well, if I take the pi over 2 out, I get x minus more normal 3. Because 3 over 2 divided by pi over 2 is just normal 3. Okay? That's a normal 3. So what's my period on this one? Well, my period is 2 pi divided by pi over 2. No! Mr. Studer. Yes. Because we have a complex fraction here. So we multiply by 2 over pi. So we multiply by 2 over pi on the top and bottom to cancel out my bottom. Pi's cancel. 2 times 2 is normal 4. So, on problems like this, where it's a radian for your period, we are not going to graph normally. We're going to graph a little differently. What we're going to do is we're going to graph with whole numbers because my period is a whole number and my phase shift is a whole number. So I'm going to go, well, let's make this 1, 2, 3, 4, 5, 6, 7, 8. So my first graph is not going to be y equals sine of x. Because if I graphed y equals sine of x, I would need radians on my x-axis. So I'm not going to graph that. My first graph is going to be y equals the sine of pi over 2x. Now, what the heck does a y equals the sine of pi over 2x look like? Well, we just said it has a period of 4. So it's going to start at 0, it's going to end at 4, and it's a sine curve. So it's going to go up, it's going to go down, and it's going to go back up again, right? So where else will it cross the x-axis? 2. Where will it hit 1 at? 1. Where will it hit -1 at? 3. The sine curve. Okay. Now, our final answer is -3 inside parentheses. So which way should I move it? To the right by 3. Because when it's inside parentheses, you do the opposite. So 1, 2, 3, there's my first point. 1, 2, 3, my second point. 1, 2, 3, third point. Fourth point. Fifth point. Looky there, that's what it's going to look like. Okay, let's do one more of those. So, okay, before I put out this, I need to factor. So 2 cosine of pi over 3 times x minus 1 plus 1. So, what's 2 pi divided by pi over 3? Because you have to multiply both the top and bottom by 3 over pi to get rid of pi over 3 on the bottom. The pi's cancel and you get 6. So, if 6 is my period, I'm going to go I might go 3 to get to wherever I'm going. All right, so I'm going to graph y, colors. I'm going to graph y equals cosine of pi over 3x first. Okay, because deals with the 6 here. So the cosine of pi over 3x, I need the period to get done in 6. Where do I start with cosine? 0, 1. I'm going to end at 6, 1. So halfway in between, I should be at -1, right? So halfway in between there and there. It didn't work out perfect, but that's all right. Should be there and there. Then the next one I'm going to graph is 2 cosine of pi over 3x. So that means I'm twice as high and twice as low. And then I'm going to subtract 1 from there. One down from the green. And then finally I'll go up by 1. Wait, Mr. Bierschbach, what are you doing? 1 to the right, Mr. Bierschbach. There we go. And then finally 1 up. Ta-da. There we are. So most of your problems will be like this, where you're on a normal axis, but 2 of them will be this crazy stuff where you're on whole numbers. Okay? So your problems are on page 127. We're going to do numbers 18, 20, 22, and 24. Just 4 problems. All right. And you know, page 127. Should we just do this for today and call it good? Yes. Then Friday we'll do cosecants and secants, which are not as hard as tangents and cotangents. And we'll say tangents and cotangents for next Tuesday. Because some people are going to be gone Friday. So if you're gone tomorrow and you get these 4 problems done, come see me so I can look at them, so I can put them in the grade book.